And now we're moving on to question 7. So if we look at question 7, it gives me my reaction and my equilibrium, and it tells me that I'm starting with 2 moles of each reactant placed in a 10-liter container, and that we will use that to calculate all equilibrium concentrations. So when we use the word reactant in an equilibrium expression, that can be a little more nebulous than in other situations. Typically, we think of reactants being on the left, right? Well, because we're at equilibrium and the reaction goes both forward and backwards, you could make a case that these are all reactants. For our purposes, we will just say that it's on the left because we are provided an equilibrium equation for it going from the left to the right, going forward. But just so you know, that can be a little confusing in these scenarios. For our purposes, though, we will say it is just our reactants on the left. So let's start with writing out our equation. So we know that initially, according to our problem, we have 2 moles in a 10-liter container. So 2 moles divided by 10 to get my molarity will be 0.2 molar. And that was just of our starting reactants. So we know these are 0. So it's going to have to shift this way because you can't ever leave any of your reactants at 0 or you can't even plug values in. So these are going to gain X. These are going to lose X. So that at equilibrium, we have 0.2 minus X for our 2 reactants. And then we just have X for each of our products. Our equilibrium constant is going to be our products concentration product divided by our reactants concentration product. Sorry. So that when we put our values in, we get effectively X squared over 0.2 minus X squared. And of course, that's equal to the 0.80. So I can take the square root of that whole thing to make it simpler to solve. And I'll get X over 0.2 minus X is equal to the square root of 0.8. The square root of 0.8 is 0.894. Oops. Don't need that. Now I'm ready to simplify this. So I am going to get, times 0.2. If I multiply both sides by 0.2 minus X, I get 0.179 minus 0.894X equals X. I'm going to add that 0.894X to each side to get my X's on one side. So I'll get 0.179 is equal to 1.894X. 1x plus 0.894. So ultimately, when I simplify my X, I get that my X equals 0.0944. So now I can plug these in to my values that I got for equilibrium. So if my X is 0.0944, these will be 0.0944 molar. These will be 0.2 minus that, which is 0.106 molar. And once again, I can plug these in to double check that my numbers jive with my equilibrium value. So 0.944 times 0.944, that's my products, divided by the concentrations of my reactants, which is 0.106. Oops, I typed in my value wrong, sorry. 0.0944 times 0.0944 divided by 0.106 divided by 0.106 gives me 0.79, which is very close to 0.80. So that should be good to go. That was problem 6. I hope that was helpful.